It's 9, 10, 11, 12, 13, 14, 15, 16, 9 through 19. 9, 10, 11, 12, 14, 15, 16, 17, 18, 19. Okay, and we also have set n is 10, 12, 14, 16, and 18. Okay, and we want to find the complement to set n. Okay, the thing to remember here is the complement that set n plus its complement equals to the universal set. So if we were to subtract set n, the complement is the universal set minus what is in set n. So if we look at set n and we cross out everything that is in the universal set that's in set n, that's going to be our complement. So 10, cross 10 out. Cross 12 out. What else do we cross out? 14, 16, 18. Everything else is in the complement. So that's going to be 9, 11, what else? 13, 15, 17, and 19. And that is our complement. Okay? That's why set n and the complement equal to the universal set. Okay? Questions there? Okay. Okay, now what does this upside down looking U symbol mean? Yeah, the intersection, right? So that means, do we need to go over intersection? Yeah, okay. The intersection is where you have, it has to be in both. The elements that are in both sides. Whereas union, you just take, okay, we're going to include everybody. We're going to take everything in set n and everything in set m, and that's going to be our union. Whereas with intersection, we look at what's in both. Okay? So if we have set n already, so I don't need to rewrite that. And we have, so we're looking at m intersect n. So set m is 1, 3, 5, 7. M 1, 3, 5, 7. Okay. There we are. So we're looking for the intersection. So what if n n is different in this set. It's a different, we have a different set n here. Okay, n is 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And the universal set is even different, so I'm just going to erase that. And we don't need the universal set for this one, so I'm just going to take it out. Okay, so we're looking to see what is the intersection. So when this means both. It has the elements that are in both sets. So whereas the union is either, you just take whatever, you take everything in both sets. Okay, so what's in both? 2 is not, 1 is not, 3 is anything. No. So therefore, since there's nothing in common, we would call this what kind? What? This would be disjoint. Okay, disjoint sets. Disjoint sets. Nothing is in common with either one. So there is no intersection. So you could also say the intersection is an empty set. Okay? Any questions there? Okay. Exponents. Do we need to go over that?
You go over 9.
The what? 9. Okay. So how about 7? We okay for 7? And of course you can use a calculator. How about 8? 8. You've got addition, multiplication, and addition. What do you do first in the order of operations? Multiply, right. You got to multiply the 15 times 10 first, and then add them up. Okay. All right. Number 9. Let's look at that. Absolute value. Let's go over the concept of absolute value. Okay. All right, we've got the absolute value absolute value negative 13. Absolute value negative 13. Okay, now absolute value means the number of units from 0. Okay, absolute value A means A units from 0. Absolute value of negative A is still A units from 0. So whether you're here at negative A or positive A, here at 0, it's still A units. Still A units. Okay? So absolute value is like parentheses in the order of operation. You have to simplify inside the absolute value before you can do anything else. So I'm just going to rewrite this. So the number of units from 0 for negative 13 is what? 13. But you got a negative outside, so that's like saying the opposite. So it's the answer is a negative 13. Okay, now this is different than parentheses. If you have parentheses minus a negative, that comes out a positive. That's like saying negative 1 times negative 13. But that is not the same thing for absolute value. You have to look at this. It's not parentheses, but number of units from 0. Okay? And then work everything else outside. All right? Questions there? Okay, so that kind of throws people off sometimes. Okay, find the sum or difference of polynomials. Any questions with that? Yes? Okay. All right, let's look at that. And this is problem 10. And we've got 6a to the 5th, and that's open parentheses, plus 7a to the 3rd. Close it, plus, and then 5a to the 5th, plus 5a to the 3rd. Okay, and we want to find the sum or difference of that. Okay, we can only add. So first thing we do is we use the variables to combine like terms. So we want to combine. Step 1, combine. Combine like terms. Okay, so we do that by looking to see an 8. We can combine an a to the 5th with what? Another a to the 5th, right? So we can combine a 6a to the 5th plus a 5a to the 5th. Now since this is plus, we're not going to change the sign, so we can just combine them directly. And then we have a 7a to the 3rd, 7a to the 3rd, and we combine that with the other, the 5a to the 3rd. So if there's a negative in front, you put the negative with it, okay? So now we're just step 2, we add or subtract the coefficients. Okay, add or subtract the coefficients. So we've got a positive 6 and a positive 5. That gives us a what? 11a to the 5th. So we don't do anything with the exponents when we're adding or subtracting. Okay? And then plus, we've got a 7 plus 5. That gives us a what? What's 7 plus 5? 12. A to the 3rd. Okay? So we combine like terms, we group together the like variable and exponents together. And once we group them together, then we add or subtract the coefficients. Depending on if the signs are the same, we add. If the signs are opposite, we subtract. Okay? And so we can't combine an a to the 5th with an a to the 3rd. So that's our answer. All right? Questions with that? All righty. Write the number 11, write the number as the product. Real number and I. Okay, well, there's nothing to multiply here, right? So anytime we have a negative inside an even radical, right, what do we have to do first, every single time, before we do anything else? Bring that negative out, make it an I, right? Okay? So we're going to go ahead and do this one. I'm not even going to ask because people tend to have some trouble with simplifying radicals. All right. So first thing we do, take that negative out, make it an I. And you do that whether you're multiplying or dividing or foiling, anything. Okay? All right, next thing, we have to simplify. Now, I always like to start, if it's even, I like to start with 4. And so, can 4 divide into a 44? 4 and what gives us 44? 11, right? So, can we get an even square root out of 4? Yeah, we can, right? So, this is I square root 4 times square root 4 times the square root of 11. So anything that you could get an even square root, you put it in one radical. Anything that's left over that you can't get an even square root, that's like your what's left over. So the square root of 4 is what? 2. So that would be 2i square root 11. And so just like 2 times 3 is 6, 3 times 2 is 6, I times 2, or 2 times I, right? And you always put the number, the real number first, okay, and imaginary. And the I always goes in front of the radical because if it's after it, it tends to get kind of like migrate into underneath the radical again, and that would be incorrect. All right, so that's our answer. Any questions there? Okay. All right, number 12. What's the first thing we do? Bring the negative out, make it a what? I, right? Do we need to see that one?
Yeah.
Okay. All right, no problem. That's why we're here. So this is the square root of negative 18 over the square root of a negative 2. All right. So we already said the first thing we do is take that negative out, make it an I, right? So that's I square root 18 over I, so we take the negative out, make it an I, square root 2. Well, just like 2 over 2 cancels out, what about I over I? They cancel out too. Anything over itself cancels out to 1 except for what? 0 over 0, right? That's the only one. You can't take nothing over nothing and get something, right? All right. So from here, we can make this all one big radical and combine 18 over 2. And let's see, can we cancel 2 and 18? 2 can go in 18 how many times? 9. So this is now the square root of 9. Can we get an even square root out of 9? Yeah. Square root of 9 is what? 3. So our answer was we had 2 complex numbers, right? 2 imaginary numbers. The i's canceled out, and we ended up simplifying it and getting a real number out of it. Okay? Questions? Okay, so real numbers, right, are all numbers except what? No, zero's real. It's everything except what? I. Real numbers are everything except I, right? Imaginary or complex numbers, where complex numbers are real, like 2 plus I is complex, or real, and imaginary is complex. So it's anything that has I in it is not real. Everything else is real, is a real number. So real numbers really pretty much cover almost everything, right? Except for the imaginary numbers. Okay, good. Question, do we need to see 13? Or are we okay with 13? Basically, you just add or subtract. What do you got to do with that negative? This negative right here, what do you got to do with that? Yeah, you got to distribute, right? Change the signs, distribute it. Both of them, everything inside the parentheses. Okay, we okay with 13? How about 14? We okay with 14? Do it? Yeah, okay. 14. Okay, we got A minus 4I times 7 plus 5I. Okay. And so basically we FOIL, just like if I were an X, but just like I were a variable, but I is not a variable because you can't substitute something in for it. And one thing that we got to remember here is I squared equals to what? I squared equals to a negative 1, right? I squared equals to negative 1. So we got to remember that, right? Just like the square root of a negative 1 equals to I, right? If we squared both sides, we'd get I squared. So just like the square root of a negative number is I squared equals to a negative 1. Okay? So we want to put that up to the side and remember that. So now we're going to FOIL. 7 times 8 is what? 56. Multiply the 2 first terms. Now we multiply the 2 outer terms. 8 times 5i 8 times 5 is 40, so that's 40i. And then negative 4i times 7, sometimes 4 is a negative 28i. And then negative 4 times 5, negative 4i times 5i is a negative what? 20. I times I is I to the second, right, I squared. Good. Can we combine like terms here? Yeah. That's the test. They're applying a new system. That's why they're testing. Okay. So hopefully that's all they got to do. Sounds like they got it working, so that's good. Okay, so 56, 40 minus 28, right, is what? That's 2. 12, right? Plus 12i. And then we got a minus 20. But I squared, we said that's a what? Negative 1. So that's negative 20 times a negative 1. Okay? So we got to change that I squared to a negative 1. So that becomes negative 20 times negative 1. Well, negative times negative is a what? Yeah, now we can combine, that's 20, so this becomes 20. So we can combine 56 plus 20. Plus 12r. So all I did here was just switch places. I didn't add or subtract. I switched places the 20 with the 12i so that we get the real numbers together. So 56 plus 20 is 76 plus 12i, and that's our answer. So so we took two complex numbers, multiplied them together by FOIL, combined like terms, changed the I squared to negative 1, combined the real numbers, and we get a new complex number. Okay, questions there? Okay. That's number 15. So we good? Can I erase that? Okay. Well, let's look at number 15, because that one's kind of involved. All right, and we've got 4 plus 3i over 5 plus 3i. Find the quotient, write the answer in standard form. Okay, now the thing about complex numbers is it's not simplified if you've got an imaginary number in the denominator. Okay, so we've got to get that I out of the denominator. We've got to do what we call rationalizing the denominator, or in this case, rationalizing would be if there's a square root, making it real. And we do that by multiplying the conjugate of the denominator. What is the conjugate? If we have 5 plus 3i, what's the conjugate of 5 plus 3i? Everything's the same except one little bitty thing. The sign, yeah. If the sign is a plus, the middle sign. If the middle sign is a plus, the conjugate is a minus. If the middle sign is a minus, then the conjugate is the plus. Okay? So we have to multiply the conjugate because when we FOIL these two together, you're going to see the I goes away. But you have to multiply 5 minus 3i over 5 minus 3i because anything over itself, except for 0 over 0, is what? Anything over itself is 1, right?
Yeah.
Anything over itself is 1. So because we can't just multiply 5 minus 3i like this, because it's not balanced. We change the number if we do that. But if we put 5 minus 3i over 5 minus 3i, that's 1, right? That's the same thing as 1. So 1 times any number is still that same number, right? So we haven't changed the number by doing this. Okay, questions with that so far? Okay, so first step, multiply the conjugate. Step 1, multiply the conjugate. Conjugate. Okay, multiply the conjugate. That's what we did here. Okay, so we're going to multiply FOIL, right? It's like we put these in parentheses. Multiply the two first terms. 4 times 5 is what? 20. And then the two outer. 4 times a negative 3i is a negative. 3 times 4 is 12i. And then we multiply the two inner. 3i times 5 is plus 15i. And then the two last. 3 times negative 3 is a negative 9i. What? Squared. Good. Questions? Okay. Now we do the same thing with the denominator. Multiply the two first. 5 times 5 is what? 25. And then the two outer, right? 5 times negative 3i is a negative 15i. And then 3i times 5 is a plus 15i again, right? But one's minus and one's plus. And then 3i times a negative 3i is a negative 9i. What? Squared. Good. Questions so far? What's that? Good question. Do they? If you had 9i squared over 9i squared by itself, you could. But because of the minus, no. You can't cancel these two out. Good question. I'll tell you what you can do. You can simplify these, but not until you simplify all of the numerator and all of the denominator. Okay? So we got to combine like terms. We can combine the i's, right, in the numerator. So that's 20. You got a negative 12i and a plus positive 15i. That'll give us a positive what? 3i, right, because you're subtracting. Minus 9, and what happens to that I squared? Changes to a negative 1, right? Questions so far? Okay, let's look at the denominator. What can we combine there? 25. What happens to the 15 i's? They cancel out. That's why we have to multiply the conjugate. When we multiply the conjugate, the i's cancel out.
So it's
minus 9. I squared is a negative 1, right? All the i's are gone now. Okay? Questions there. So now, this will be 20 plus 3i plus 9, right? And 25 plus 9, right? All righty, so far so good. So we got to combine the 20 and the 9, right? The two real numbers together, the real part together. 25 plus 9, that's going to be a 30 what? 34, right. Good. So 20 plus 9, that's a 29 plus 3i over 34. Since there's nothing to cancel, right? That's our answer. Okay. Now, if you had to cancel, you would have to split it, then cancel. You can't cancel like here or here because of the plus. So you can also write this as 29 over 34 plus 3i over 34. You can split it and write it like that. That's another way to write this. And it's only this way that you can cancel. Well, there's nothing to cancel, so it don't matter anyways. But this is the only way that you can cancel it, by splitting it. Okay? Any questions there? All right. So with this one, you just got to be careful and just take your time with it. All right. Okay. So we are good there. 15. We're done with that. Number 16. Factoring. Everybody likes factoring, right? No. Okay. Not usually. But, okay, question for 16. Do we need to see 16? Or are we okay? We good? We good? Yeah? Okay. All right. Find the product. Basically, you're just foiling, right? We good there? Okay, good. All right, number 18. Solve. We're just solving. We've got x's on both sides. Do we need to see that one? Let's go ahead and do that one. Number 18, we've got negative 7x minus 4 equals 2x minus 7. Okay, now you can start out one of 4 ways. You can either add the 7x, subtract the 1x, add 4, or add 7. You can start off one of 4 ways. You can have 4 people in this front row, and they all start off a different way, but they all should end up with the same answer. Okay? I like to try to keep the x's positive, so I would apply a plus 7x. Because at the end, you don't have to mess with a negative. Okay? So the 7x's, they go to 0. All right? And so you get negative 4 equals to 1x plus 7x is what? 8x minus 7. All right, now what do we do? You got to isolate that x, right?
Yes, sir.
So what now? What's the next thing? We got to get that x by itself.
Divide 7.
Divide 7. Divide 7. Divide 7. Divide 7. Like that. You sure you don't want to do that, right? If this is a minus 7, and that'll only give you 1. So that you want this to go to 0. Add, right? Put the opposite. Plus 8. Apply a plus 8. And so, or 7 rather, not 8. Plus 7. Where did I get 8 from? Plus 7. 7. Okay, and so you got negative 7 and positive 7. What happens to the 7s? They cancel. They become what number? 0. They become 0, right? But we don't write 8x minus 0. We just leave it off. But that's really what's going on, right? And you got 7 minus 4 is what? 3. Okay, we got to do something with that 8, right, in order to isolate that x. Now what do we do? Divide by 8. Divide by 8. Because the 8, what happens to the 8s? They become what number?
1.
1, right. But we don't normally write 1x, right? We leave the 1 off. So our answer is 3 over 8. Okay? Questions there? Alrighty. 19. Literal equations. Anytime we got a denominator, and we're trying to solve, what do we do to get rid of that denominator? And it's every time you want to get rid of that denominator first before you do anything. Well, let's go ahead and do this problem. We're in good shape for time. We've got v equals to 1/3 b h, and we're solving for h. Okay? All right. We've got a denominator. We got a fraction. We don't want that fraction. We want to get that fraction out of there. Well, the 3, this is adding, subtracting, multiplying, or dividing into the h. Is the 3 adding? No, it's not adding, right? Not subtracting. Is it? Yeah, it's 1/3 times h, right? But it's 3 divided by h, right? So to get rid of that denominator, what do we multiply to both sides? 3. Whatever this is, we multiply it out. So the 3's, they cancel out, they become 1, right? So this is now 3 times v equals to b times h. What are we solving for? H. You want to keep asking yourself that. Okay? So that means, what operation is there between b and h? Adding, subtracting, multiplying, or dividing. Yeah, it's multiplying, so you got to divide the b, right? So that's h equals to 3b over b. Okay? We don't know what b is. We don't know what b is. So we can't do any calculation. There's no calculation involved. It's all a process of algebra. Okay, all an algebraic process. It's the same thing as if we had 1/3 2 times h, right? We multiply the 3 and then divide the 2, right? So the process is the same with literal equations as it is with numbers. So if you're not sure, substitute the letters for numbers and then work it from there. All right, any questions? All right, 20. Do we need to see 20? We good with 20? You want to say it? Okay. If you're good with 20, you can go ahead and go. Oh, let me get attendance here real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At least 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're good. Okay. So please leave questions so that we can go through this real quick. Okay, 20. We've got 5x plus 9 greater than or equal to 6x plus 17. Okay, so basically we're doing the same thing. Hey guys, thank you. Basically we're doing the same thing as if we had an equal to sign, right? We want to combine the x's, right? So what do we do? You tell me what we're going to do. Well, If we added 5x, that'd make it 5 times 5 plus 5, that's 10. So we don't want to add, we want to subtract, right? Minus 5x, minus 5x. Okay? Because that makes it go to 0, right? If we added 5, that would give us 10. And that doesn't do us any good. So that'd be 9 is greater than or equal to 6 minus 5 is 1x plus 17. Okay, so what do we do with the 17? Minus 17, minus 17. But you want to put the larger number, whether it's positive or negative, on top. Because when you subtract, you got to make sure you subtract them correctly. So 17 minus 9 is what? What's 17 minus 9? 8, right? Yeah. Okay. So let me see how they answer. If this answer was set notation, or how do they answer it? Sometimes they answer it differently. Okay, so they did it in interval notation. All right, so we want to put on a number line. So they had us find a number line and then write on a number line and then put it in interval notation. So here's A. So is the solution greater than 8 or less than 8? Yeah, x is on the small end, so it's less than. And it's less than or equal to, so it's a bracket. It's a closed bracket. Because x is on the small end. So that would be the same thing as if you wrote it like this. Right? X is on the small end, x is on the small end. And the arrow always gets infinity, right? So therefore, this would be written in interval notation from negative infinity, rather. Negative infinity, that's a funny looking infinity sign. There we go. To 8, and it's closed at 8. So that's your answer in interval notation, that's your answer on a number line. Okay? So the number line, you want to work this out and actually do the number line, because that'll help. The number line will help you come up with your answer in interval notation. Okay. All right. Any other questions there?